All right, guys. Well, thank you all for joining us this morning on our Thursday morning coffee break. My name is Leroy Willow, a sales engineer in our Grand Junction office. Joining me today is Sterling Minter, Director of Sales for AQC Industries. And our topic for today is why duct leakage matters. We're going to be showing some great products that AQC has to offer to help eliminate that problem. With that, I'm going to turn it over to Sterling to get rolling.
Okay, thank you. Appreciate it, Leroy, and I appreciate everyone joining us today. So we're going to kind of run through this quickly. First thing we want to talk about is the myths of, does duct leakage really matter? And the myths are not really, because the cost of a CFM is pretty minimal in comparison to what it might cost to stop the leakage, which is, that return on investment. If it's going to cost us $20,000 more to get a better leakage system, do we really want to spend the money? We've been using insulated metal for years, and we pretty much know the ins and outs, and we kind of work around it. And part of the ways as engineers we've done that is we've tried to just increase insulation and figure that'll solve the problem. But it doesn't, because leaking air, we think about leaking air in a conditioned space and we think, oh, no big deal. It's in the space, but the reality is the air that's leaking out of duct doesn't have velocity, doesn't have airflow, so it never reaches where it needs to be. So even in the conditioned space, but especially exterior duct is an issue. And we have that assumption that just a little teeny bit of maintenance and we can keep it from being a real issue. So if we just look at the first cost of the CFM, it's going to average somewhere between $450 and $550 across the country. And so if we take a SMACNA Class 6, which is where most metal projects lie, unless you require it to be greater, a 4-bolt flange, a TDF type flange, they're going to be Class 6, maybe even Class 12, and that's day one. It's going to continue to get worse as time goes. But if you look at 1-inch static, so it's going to leak 6 CFM at 100 square foot of duct. And at 4 inches, it's going to leak about 17 CFM. So you're looking at about a $30 cost per 100 square foot of duct versus, or maybe an 85 for the higher pressure systems. And so we think it's not that big of a deal. But then there's that compound interest theory, meaning if that air escapes, then we have to replace that air. Some of that air is going to escape. And so it does get costly. And so if we look at this project here, this is the Cloquet School District in Minnesota, 23,000 square foot of duct. At 1-inch static, it's going to cost them roughly $7,000 if we just look at a $5 CFM cost. At 4 inches, which we know it's going to be, I think this operates actually at 6, you're going to look at it closer to $20,000. And so when you start to equate that and compare it to a Class 1 leakage, now at Class 1, you're leaking 1 CFM per 100 square foot. And at the higher 4-inch, you're only leaking 3. So now you're looking at that same $5 per CFM. And all of a sudden, on the smaller 1-inch, we're only spending $1,100 in wasted energy. And at the 4-inch, we're only spending $3,500 compared to that $20,000. So now we start to see the real savings. So the question is, how do we determine all this information? And so what AQC has is we have on our website, we have a calculator. And so we're going to kind of jump out and jump over there real quick. And this is something anyone can use. We can allow engineers to use it, contractors to use it. But if we go to the energy calculator on our website, we're able to put in the project information. We can pick the state and we can change the city, and that changes our gas rates and our electric rates. And then we put in the Q duct, which is one of our rooftop duct systems. And we put it's typically an R12 system. It's going to be a Class 1 leakage. And we compare it to a Class 6 R12 similar insulation on an exterior duct. And this takes the information that we put in the duct area of the system, the size and pressure of the class, and it will tell us the difference in lost energy on a 10-year period. So just looking right here, it's 12,000. If we don't want to take what's automatically filled, and this is by SMACNA data and weather data, you also have the ability to go into the advanced and change the heating days, the cooling days, and the fan operation. And all these things can be changed at will. And what that does for us is it allows us to get a good comparison of one system to another. So if we go back to that cloquet school, we can see that comparing a R12 Q duct system, our rooftop system, which is a class 1 leakage, basically doesn't leak, and we compare that to a competitive system, typical metal duct at class 6, same R12 insulation, you're looking at an energy difference of about $231,000 over the course of 10 years. And so this is a huge savings that you can see by simply utilizing and stopping leakage, because we have to understand metal duct leaks, unless you require it to be welded, unless you require higher leak testing. Typically, we just say test it per SMACNA, which is going to be class 6. But we need to require heavy because metal duct has thermal breaks. The flanges are typically not insulated. They usually insulate on either side of the flanges of exterior duct. Interior duct, they pull it tight. If that insulation gets compressed, it loses its R value. Your insulation can get damaged, the metal can get damaged, and all this starts to equate to additional losses. There's 2 trades involved because you've got your metal and you've got your insulator. And the reality is insulation has never been required or even supposed to stop leaking air. So as long as your duct is leaking in an exterior application especially, you're always going to have problems. So doesn't matter how good of a job, it's plain and simple. If air gets out, if wanted stuff gets out, then your unwanted stuff is going to get in. And that's kind of what these little pictures show, is that if you've got a duct system that's allowing air to get out, then it's going to allow water to get in. And so you can't just throw insulation at it and think you're going to fix the problem. Adding R value without improving the duct leakage is just a waste. You haven't done anything but spent more money on insulation, because insulation isn't meant to stop leakage. And applying a different jacket. We've seen years where I think we went through a period, I'm going to say 15, maybe 20 years ago, where we used EPDM rubbers. And if the system blew up like a balloon, then you knew it was at least holding in the air. But if it didn't stop the leaking duct. The duct was still leaking. 3 inches of wet insulation is no better than 2 inches of wet insulation. Picture yourself, you're wearing a sweater, you're in a boat, you fall in the water. Well, if you're wearing 2 sweaters, you're still going to be just as cold if you fall in the water. You're not doing any better. So it's the same thing when we look at insulation, because the true cost when we don't stop the leakage is not just the loss of the CFM. Wet insulation is 85% ineffective. It does not do what it's supposed to do. It contributes to mold and biological growth. So now you have even bigger issues. It causes degradation and duct corrosion on your galvanized ducting, unless you've ordered stainless. And it just increases your required maintenance. So we have to kind of have a paradigm shift. We have to get away from just allowing SMACNA class 6, and even SMACNA is looking to increasing their requirements. But we have to switch. We have to have that shift to a SMACNA class 1. We have to say, no, stop the leakage first. And if we stop the leakage, we reduce the energy consumption. We minimize, we eliminate water into the duct and the insulation if it's exterior ducting. We reduce opportunity for mold and biological growth. So now we get improved indoor air quality, which is a huge function we're trying to move to these days. And we reduce the need for long-term maintenance. Now, what AQC brings to the table and what Long provides for us is introduction to these product lines. The first we have is Blue Duct. Blue Duct is an underground duct application. That's where it's designed. That's where it's supposed to be. We have PAL phenolic duct. Many of you may be familiar with Kingspan Cool Duct, 1st generation phenolic. This is 2nd generation phenolic. It's also a Kingspan product. Kingspan PAL, and then that's for the interior of the duct. We have Q Duct, which is our patented rooftop system. And this is one we quite frankly can't seem to make fast enough these days. And so if we just look at a quick comparison, Blue Duct underground, you'll see PVC coated, but quite frankly, folks, you shouldn't be putting metal duct in the ground, not galvanized duct anyway. You can coat it all you want. It's going to scratch off. It's going to leak. It's going to allow water. It's going to fail. Needs to be encased in concrete, needs to be insulated. FRP, fiberglass reinforced plastic, it's a good product, can work very well. It often is not a complete system, has to transition to metal plenums, PVC coated. So again, you start to have issues. It's got toxic resins and things of that nature that contractors don't like. The blue duct, on the other hand, will be a complete system from the mechanical room till it penetrates slab. It'll all be the blue duct system, although in this hospital they used black because they didn't want to see the color, but we provide everything they need to do that project. When we go outside, we start to look at basically three components. You've got galvanized insulated duct, you've got galvanized double wall duct where your insulation's in between your metal. There's a product out there called Thermoduct, which is another good phenolic duct system. Where they failed was they kept the same 4-bolt flange that metal has, and so it leaks. And because it leaks, it allows water infiltration, it allows leaking air, and it loses thermal efficiency. Even if you look at this metal system here, you can see these supports run down inside the insulation. They're going to, one, if they're screwed into the duct, create additional leakage. And two, they're going to allow water to penetrate. Once that insulation gets wet, it's going to begin to fail. So we have our Q-duct system. It's a interlocking male-female joint system. There are no metal flanges, no thermal breaks. It has a patented Q-lock, and that Q-lock is a quadruple seal, and that gets us to less than 0.5% leakage. It is a class 1 leakage. It's jacketed then with a 6-ply zero permeable jacket, 4 layers of aluminum, 2 layers of phenolic, and then a venture jacket on top of that. We have sloped roof. We have Q rails, Q lock here where you can see the interlocking system. Our Q rail is a support system that kind of reinforces to the inside skeleton of the duct and is very easy to work with. We have a sloped roof that goes on top and adds additional R value. And then on the inside, we have just a single layer of the pre-insulated PAL phenolic by Kingspan. So it's not as big a deal on the inside, but underground and rooftop duct leakage is a huge money spender because you cannot have a good sealed insulated system if it's allowing water in and if it's getting wet. So that's the quick coffee break. I hope you enjoyed it. For additional specification sheets or additional information, just reach out to your Long representative and they can give you more information on AQC, and we'd be glad to work with you and have our design teams work with you and do anything we can. So I'm going to turn this back over to Leroy.
Thanks, Sterling. Excellent job. So we're going to jump right into this week's prizes. We have a GCI outdoor rocking chair. We got some awesome Captain America knee-high socks with wings on them. And we have a North Face sleeping bag rated to 40 degrees. Please join us again next week when Aaron Morris gives a presentation on Halton's pollution control units. Thank you very much, everybody.
Thanks, everybody. Take care. Have a great day.